Broadcast is now starting. All attendees are in listen-only mode.
Oh, sorry. Wasn't I supposed to start? Is that okay?
Yeah, sure. Hey, everybody. Omar, you want to introduce Jose and Rod?
Yeah. How do you guys want to be introduced?
I'm a security researcher. That's pretty much what I do.
Yeah, we're already broadcasting, so go ahead and announce.
Oh, okay. So, well, good morning, everybody, and thank you for being here on a Sunday. I'm here with Jose, and today we're gonna speak about the adversarial emulation using the Splunk attack range as a tool. You want to talk a little bit about yourself, Jose?
Yeah. I'm Jose Hernandez, colleague here of Rod and Splunk. We're both principal researchers, and yeah, we're just super excited here to share how we're using the attack range not only to do adversarial emulations, but how you can use it as well.
Okay. Jose, I think you're set to be able to present if you want to go ahead and present.
Yep. Can you see my screen?
Yeah, we can see your presentation. Just so everybody knows, all the support for this will be done in the Discord channel, so please join the Discord channel. If you don't know how to join it, it's pretty simple. Go to jungle.io, and it's misspelled jungle. It's June because we're in the month of June, June, and then gle.io. If you go to jungle.io, you'll see join Discord servers. Click on that, and then join the Texas Cyber Discord channel and hop into track 1, and we'll have a team there helping answer questions and answers. And Rod and Jose, you guys are in there, right?
Yeah.
Yes.
Okay, they'll be in there as well to help you. So I will stop talking and hand it over to you guys. And also, Omar is in the channel in case you need any other assistance.
Hey, everyone.
All right. Thank you, Joseph.
So basically, what we're gonna do today? Yeah, I can see the screen. We're ready to go. So today we're gonna talk about adversarial emulation, and we're gonna do a lab that is built on a Splunk attack range. This is a tool that was developed by the Splunk security research team, and it's open source, available to everybody, and you can modify it, and you can use it for all kinds of things. And you will see that. We'll go in very detail on it. Next slide, please. So this is who we are. I'm a principal security researcher, engineer. I work with Jose at the Splunk research team. I worked at Prolexic, which is now Akamai. Used to work at a UBA startup called Caspita, was acquired by Splunk. Currently Splunk, one of the co-founders of Hack Miami, Pacific Hackers, meetups and conferences, and I created command and control and no core CTF. Jose, do you want to go ahead and introduce yourself?
Yeah. Yeah, I'm also an old school Splunk Prolexic engineer. After Prolexic, I ended up actually at Splunk for a long time, and then decided to co-found my own company called Xanage, which got recently acquired by Oracle. It's now their web application firewall and DDoS cloud service, and came back to Splunk to focus on producing better detections. And yeah.
All right, so next, please. All right, so what is the Splunk attack range? The Splunk attack range is a framework that allows the security analyst and an operator to quickly and repeatedly replicate or emulate attacks and generate data as close as what is called in machine learning ground truth. Ground truth is basically as close to reality as you can get data. This is a fundamental problem, not only for analysts, but for researchers. We're always dealing with synthetic data. Synthetic data is logs that are produced by scripts or things that are too artificial. Usually they do not have any type of noise like you have in a normal or real network, for example, or you have a lot of applications that would run into a standard workstation, and we're going to talk about it as we move on, and we would revise the concept of golden, what a golden image is why it's important when you are replicating or emulating adversarial techniques. So, sorry, the reason this was developed was to try to get as close as possible to ground truth, and also produce some sort of data that was readable, that was sparse, that was able to be analyzed, and as you will see as well, you'll be able to build upon it responses. So it's because we do have a plugins for SOAR as well. So next, where can you find it? You can find this Splunk attack range in GitHub. Basically, what you do is you clone the repository, and all the code will be there. Where we will go in detail how you customize it in order to make it happen, but it's public and available for everybody. You can do that right now. So let's continue, please. So here's a little bit of the architecture. So mainly there are two ways to build the attack range. You can do Vagrant, and Vagrant will build it locally, or you can do Terraform, which will build it in the cloud. So if I do Vagrant, and both of them are based on architecture and from the orchestration perspective in Ansible, you can on both modes, you have a Splunk server, you have a domain controller, you may have a Windows server without a domain controller, and you can have a Windows client, which is a Windows 10 workstation. You also get like I said before, a Splunk server, which is based on Ubuntu, and in this Splunk server, you will have included an adversarial emulation framework, well known as Caldera, which is developed by MITRE. We do have plans at one point to do Mac OS, but that's not released yet. On the Terraform part, you can build as well a Active Directory domain controller, a Windows server, a Windows client, a Ubuntu with Caldera, and Splunk. Oh, and Kali. You can actually have a Kali machine that we'll be seeing examples of how to use the Kali inside the internal or the network that is created or configured when you build up the attack range. Let's move on. So I'm not sure if you want to jump in here, Jose, and explain a little bit about the serverless infrastructure and the Kubernetes part. But this is also a part of what we're developing. Is eventually we're going to have, and I can give a little bit of a hint. We're going to have a cloud based and attacks Splunk attack range, meaning we're just not going to have what we have right now, which is heavily based on endpoint and some network, but we're also going to have cloud-based attacks. So we're working on emulating the infrastructure and the environments that are usually found on the cloud vendors. And eventually we're gonna release. We're very close to doing a big release of a cloud-based attack range. That's common, and we have a colleague named Patrick Varais who's doing an amazing job. developing and leading this effort, as well as Jose. So you should expect this in the near future. We're not going to focus today on the cloud-based attacks, but it's important for you to know that that is coming. Next one.
Actually, Ross, before we jump out, I just want to make a note. So maybe something that wasn't necessarily too explicit, and just to add a little color. The vagrant mode of the attack range is mainly built for local development. Meanwhile, the Terraform mode, as Rob pointed out, it's heavily focused on like it's a lot of endpoint data that you get out of it. So it's mainly focused for endpoints. The cloud attack range is really built around collecting data and launching simulations against specifically native cloud services, right? So Elastic Container Storage, ECS, also the serverless components of that, so like S3, Lambda, any Lambda services, and to Rod's point, the code is already out there. At Clearly Straight, we're still testing and we're still building attack simulations for these kind of environments, but the code to build the environment is out there. So if you ever wanted to do manual testing, you can get started with that tomorrow or today, actually.
Cool. So, all right. So here's a little bit of more architecture, and this can get a little bit extensive, to be honest. I can tell you this as a researcher, as a pen tester, as a at one point I was a heavy IR person when I was at the PLX CERT. It's fundamental for anybody to understand adversaries and attacks to have your own lab. You know, they say that in martial arts, you can only fight what you train. So if you don't have anywhere to replicate the attacks, to understand, to see the logs, to see how an attack looks like, it's definitely a disadvantage. It requires, this is an ability that is only acquired by experience, by somebody that has been in the field for many years, and because they've been exposed to this type of technologies and seen the logs and tamper with them, they kind of recognize them. But if you are studying, or even if you are good at certain platforms but not good at others, it's still a disadvantage. So the Splunk attack range is, in my opinion, is a battlefield enhancer, because this will help you prepare. This will help you understand how the logs look like. This will help you replicate a technique and then find it, like we're going to see in Splunk, and see, oh, so this is the event ID I need to look for, or oh, this is the process that gets spun, or this is the directory I need to look for if I'm trying to catch something. So in these environments, like I said before, we have Windows domain controller, Windows server, Windows workstation, a Kali machine, a Splunk server, and a Phantom server. I had to warn you, if you decide to do this via Vagrant, you better have like all kinds of great hardware with you, because it can get very big, and that may slow your machine. So our suggestion is, if you, because many times talking about code as infrastructure type of tool, you can destroy and deploy these things. You don't have to keep them open. You'll see that very soon. That you can enable it, build it, do your thing, destroy it. You don't have to keep this running. On the local part, it might be a little more difficult, because you are going to have to download all these images. You're going to have to start all this operating systems, and it will be there for you. But you know, unless you have like 32 or 64 gigs of RAM and terabytes of hard drive, this can be a problem. Now, this is a good problem to have. During my career, there were times that I had to basically request an entire ESXi server. Right? You talked about ESXi and VMware hypervisors now as legacy, right? What we used to you had to put a request. You had to even look at the rack space and see if they have space for an ESXi server. So we had come a long way from that. Now, basically, you just have a code that you adjust, and it builds this up, downloads the ISOs. Your deck will be ready. Your users and passwords will be already configured, and you will be ready to go. The only thing I'm going to warn you is that if you're going to do this locally, you got to be careful because it's quite a bit of a load for a workstation, and unless you have something that is 32 or 64 gigs of RAM at least, you're gonna have trouble. It's gonna slow down, but you can do easily a Windows server, a Kali machine, and the Splunk server. That shouldn't take you that much. Not sure if you want to make some comment on the sources, the source types that I'm seeing there. I was gonna touch on them.
Yeah, actually, and if you don't mind, Rob, before we jump into the source types, I just want to make a note that this is the full acceptable environment. But for example, if you're using Vagrant, to Rod's point, you probably don't want to spin all of this up. It's gonna make any decent MacBook Pro hot enough to fry an egg. But you can pick and choose what comes up, and actually by default, the attack range only brings up the Splunk server and an Active Directory server to attack. So, and the Splunk server, as Rod's pointed out a little bit earlier, also contains Caldera. So Splunk server has basically it's going to collect all the events from Active Directory, and also has Caldera for you to attack, and Atomic Red Team on the Active Directory for you to be able to attack through it too as well. Kali, the Windows 10 servers, the regular Windows server, and Phantom are all optional instances that you can just flip on if you need to. But if it's okay with you, I can dig into the data sources that we're seeing here.
Yeah, well, if you want, you want to tell us a little bit of basically what we're looking for as far as maybe we should start with Windows and then talk a little bit about the future with OX Query.
Yeah. So one of the cool things and one of the reasons, again, we built the attack ranges, we were seeing ourselves like building attack environments consistently, and it would take us days. And we needed usually clean environments to test new attacks on, right? We didn't want environments that were tainted with previous attacks, we're emulating in it. And so in order to do that, we really needed like a really good setup. Specifically, we started with Windows, which is where we do a lot of the analysis on. But
oh, looks like we lost your audio. I can pick up on here. So what we have on the Windows 10 side is a number of source types that start from Sysmon, Windows event logs, and Atomic Red Team results. And all of this is grabbed by the universal forwarder and sent into Splunk. Once this is sent to Splunk, obviously, you had to have, depending on the source types, the applicable technology additions that you can download from Splunk base, the Common Information Model application, if applicable, the ESEU, which is the Enterprise Security Content Updates, and there's a new framework which would allow us to streamline new content, new searches via a CI/CD process. So I think Jose's back.
yeah. Sorry about that.
Okay, cool. Okay.
Yeah, Comcast doesn't like me today. Sorry about that. But yeah, exactly to the point. I'm not sure where I left off, but data sources in there are Sysmon, and we used out of the box Swiss on security Sysmon configuration, so it's pretty realistic. On the network side, we use Splunk Streams, which is very feature parallel to Zeek. Actually, one of our bucket list items is to add Zeek or a Zeek server into the attack range. And then we have a bunch of, like Rod, I think you mentioned this earlier, we have a bunch of other TAs to collect like Windows event logs, Windows application logs. So we cover the endpoint, specifically endpoint events for SysMon, right? Process creation, memory access. We cover operating system, right? So application logs, security logs, et cetera. And then also the network stack using streams.
Stream. It
And
is
then
also, yeah, it is also important to mention that for the standard baseline and build of this, you don't have to install anything. By the time you spin up the range, all the appropriate TAs and add-ons and applications will be installed. But it's important for you to know that you can always add more or customize it. Jose, do you want to tell us a little bit about the future work with Mac OS? Because there seems to be a shift, mostly in Silicon Valley, towards what I call the Okta Mac OS type of authentication type of model, where companies are walking away from Windows-based networks. You there? It looks like he's having trouble again. Okay, so basically, I can add a little bit. The future work that we're looking at would include OS Query, and it would include OS Query because, as I just said it, there is definitely a shift in many companies, at least that we see in Silicon Valley, where they're using other type of domain type of authentication, federation authentication, mostly using things such as Okta, for example, or Ping, or any other type of product. And the workstations are no longer Windows. In the last two startups that I've been, which of course are not enterprises, but they definitely at one point reach a nice size. We only had a Windows computer, or it was actually at one point it was a virtual machine for the accountant. We didn't even use Windows for anything. So, and this is happening. It's happening, and we know about it. So we're starting to look at other sources and other types of authentication environments to add them to the range as well. So let's.
Sorry
yeah.
again. I think my internet is suffering. But yeah, we're working basically. I mean, we're working heavily on trying to get a OS Query basically server instance and agents deployed as part of the attack range, so we can collect specifically like a Mac OS or even Linux endpoint logs using this. And that's some of the Mac work. There's a big challenge with Mac OS emulation that AWS doesn't today support the ability for you to spin up a Mac OS instance in EC2. So one of the things that we've been looking at is how do we do that, right? Like in Terraform mode, it mainly is built and centered around running in AWS, and because we cannot emulate a Mac OS instance in there, it kind of limits us. So likely at the beginning, Mac OS support will be limited to the Vagrant mode and eventually expanded. But we're somewhat at the mercy of the cloud provider that we leverage out of the box here, right?
All right, let's move on. All right, so here's, maybe you can chime in here as well, because you have a deeper knowledge than me on the AWS cost, the cost jungle, to call it a certain way.
Yeah, so the attack range instance type. So first in Terraform mode it's built for AWS, and the instance type we use is T2 2XL. So that if you price out the cost of running a T2 2XL instance, and specifically, usually again we average out you're gonna be running the attack range for about 3 hours, 4 hours is what we, again, like the typical workflow where like we'll take about 3 or 4 hours to develop a detection, then destroy it, rebuild it, and a month. And if you do this a few times a month, There's a cost estimate calculated down there, but it roughly comes out to no more than I think it's like $200 a month if you're building a full range consistently, right? Like where you're doing this every day, in a daily uses where again you're building it for 3 or 4 hours, destroying it, building 3 or 4 hours more, destroying. And this is specific again for the Splunk server, a Phantom or Kali, right? So usually, well, usually we don't use both typically, but sometimes we do. So I factored in one or the other, and it went some sort of Windows endpoint, Windows client or Windows domain controller. If you just leave those up again 24/7 running, you're looking at about $200 cost. Again, if your workflow is usually build, destroy, you're not. It usually that actually drops down a whole lot more since you're not keeping those instances running, and I think it drops down to about like $15 roughly a month. Again, depending on your usage and how long you keep the instances up.
Cool. Let's move on. So here's something that you certainly want to look at right now, and I know you're probably having your coffee and waking up, but this is something that you need to look at right now, because when we start doing the exercises, here's where you find the evil. The evil, or the data from the attacks, will go into the following indexes. The index will be equal win. We're gonna walk you through this, by the way, but you need to understand when you look at the Splunk search that when you type index equal win or main or attack, here's what the logs are gonna go. And in case, and this happens sometimes when this is common with ephemeral environments. Sometimes there are hiccups. Sometimes, you are, for example, pulling an app from a specific website, and you get either a 403 or a 404, and then the environment gets built, but the app is missing. So it's important for you to understand the indexes that you're going to be looking at, and there should be data in it. If there is no data in it, we have an issue. So if you have, for example, if you're building, for example, this out of AWS, you simply destroy the environment and redo it again. This is almost a tip when operating the range. Many times, because of latency of the internet or what have you, errors in the servers, there might be hiccups where certain things cannot install. If you don't see them, my suggestion is to destroy it. Remember, this is ephemeral. Doesn't matter. What will happen is it will take you another. It takes us an average of 10 or 15 minutes to build a full range from AWS. But if you see things like this, like for example, you go index equals win, and for example, you don't see PowerShell logs. If you execute it, obviously a PowerShell based attack, or if you look at network logs via Splunk Stream, and remember, when you're looking at Stream has to be configured to see specific ports. So if you're looking at you're trying to emulate, for example, a specific attack that is not under the standard, you may have to modify a little bit of Stream in order to see it. On the Sysmon logs, we use I believe it's a policy for Sysmon that is the heaviest and the highest on auditing and getting logs from the workstations and servers, and all of those go into index equal win. So remember, Windows workstation, Sysmon logs, PowerShell logs go into the win index. The network logs with Splunk Stream go into main, and of course the attack simulation logs from Atomic Red Team. Remember, we have two attack adversary simulation frameworks. One of them is Atomic Red Team and Caldera, and we'll go over it in a few minutes. Next slide, please. So again, we are at one point, and this is again something that we are developing on, but we want you to understand that we're trying to adapt this framework to obviously what's happening in the market, in the industry, and in the field. The goal is to get you the closest environment to ground truth, and that's what will make leverage your research and your defense posture. So one of the things that we're doing is there will be a deployment with Kubernetes that can be activated via attackrange.conf. Well, I will show you in a minute how we do that. We will be working with an amazing tool developed by some of the Splunk departments called Splunk Connect for Kubernetes. Basically, this gets absolutely everything inside a cluster if you're auditing it. And we're also working on serverless deployment, basically based on Lambda and REST APIs, using DynamoDBs and S3 buckets. But we're not gonna delve into that. But for those who are new into the AWS world, usually the main sources of logs are either CloudWatch or CloudTrail. I'm sure at one point we will come up with a seminar for the cloud-based attacks, but not right now. Next. All right. So what do I do now that I want to build the attack range? The attack range, as I said before, can be found on GitHub. You can basically clone it, like you see in the prerequisite. Attack range is based on Python 3. And if you still have an environment of Python 2.7, you may have to use a Python module called virtual env and create a Python 3 environment, activate it, and then you can use the popular packet install management tool for Python, pip, and then install the requirements. Once you start the requirements, it will basically have all the binaries and all the libraries that you need. You will still, if you're using AWS, you will have to initiate Terraform as well. You have to go into the Terraform folder and initiate it. If you're using Vagrant, you can do brew, and you're gonna need VirtualBox as well. And again, when you are looking at the Vagrant execution of this, please make sure you do not over configure the range. If you put everything in it, we're talking several machines. It will take quite a bit of time, and it will probably slow your computer to a crawl. So I would suggest not to. If you have, for example, usually a standard issue MacBook Pro, they will give you 16 gigabytes of RAM, probably around 500 gigabytes, up to a terabyte of hard drive, and no more than 3 machines per iteration. And then you may have to destroy it, reconfigure it. That's the price of limitation in terms of resources. If you're using a Windows-based computer, I would say that the same rule applies. I'm not sure, Jose, if you want to add on to this.
Yeah, I mean, so specifically for configuring the attack range to run in Vagrant, it's pretty straightforward. The main requirement here is to have a VirtualBox and Vagrant, obviously. Again, for those of you not familiar with Vagrant, Vagrant is it's basically a utility that allows you to manage through a command line interface different VirtualBox machines, and they call them boxes. Well, actually, not just VirtualBox. Vagrant supports also VMware and a few other local emulation engines, but mainly it was built originally around VirtualBox. Everything else is pretty straightforward. It's, clone the project. We recommend for everyone to use virtual environments for Python when installing our requirements. You don't want to taint your system libraries with the dependencies that the system the attack range has. So, which is the second step in prerequisites, right? You install a virtual environment, you activate a Python 3 virtual environment, and then you go ahead and install the requirements. But besides that, it's again, if you're running installation on Mac OS, it's as simple as again, this also assumes you have brew, but as simple as just do a brew install VirtualBox, brew install Vagrant, and just editing the conf file.
Right, and also, sorry, one quick comment. As you move on with your environment or your lab, and I can tell you this based on my experience, if you are updating or you're building new machines, it is important that you keep not only Vagrant but VirtualBox up to date. If not, you may have issues. So always remember that. Next.
Yep.
Okay. You want to add something?
On the Terraform side, yeah. So today later on after the slides and we walked through. We're gonna give you a range in Terraform. We should have probably said it at the beginning. I'm sorry, but the Terraform installation instruction it's a little bit more. There's a lot more steps involved, but it's somewhat like riding the bike. Once you've configured it once, first you never have to configure it again, unless you change accounts. But it's pretty straightforward to do afterwards. The installation instruction here is the prerequisites are the same. You know, clone the project, install virtual env, and then install the dependencies under that virtual environment. If you're running on Mac OS X, you do a brew install Terraform to get the actual Terraform binary, or you can just literally download it from the Terraform site and put it in local bin. But the step after this is basically initialize Terraform. And this the second step here, run Terraform init. What it does is it's going to go ahead and pull out all the plugins that Terraform is going to use and install it locally. And then the next step is installing the AWS CLI, since the Terraform installation under the hood leverages AWS Boto for doing a lot of the building and instantiation. And so you install AWS CLI, then you do AWS configure, you pass along your API keys that you generated in AWS under an AMI user. Once you have the AMI user configure or your AWS configure locally, then you use keygen, you can generate a key pair. That key pair you're going to go ahead and upload on the region that you're going to build on. Give it whatever name. By default, we call the key pair in the conf file the attack range key pair, because we're not creative with names. But you can also alternatively also create the key pair in AWS and download it locally, as long as, again, as long as you set the right key pair on the attackrange.conf. There's a parameter in there to actually point to what key pair, what private key you're using. And again, that key needs to exist on AWS. And then the last step, the step before the last here is just accept the terms for using the Ubuntu AMI images for AWS account. Otherwise, when you build, you get some weird error saying, hey, you got to go to the marketplace for AWS to actually use these images. It's an AWS thing. And that's pretty much it. The final step is, again, just make sure you change your passwords and set any allow list under the attackrange.conf, and obviously update whatever. If you change your key pair name to something else, make sure it's listed on there, and configure the environment. But again, there's a whole lot more steps involved, but one, at the end of this, I can walk you through building one from scratch, but we'll also be providing whomever's in the workshop here, will be providing already pre-built ranges, so you can see what the configuration looks like anyways.
Right.
I'm also going to drop in Discord. Sorry, Rada. I'm also going to drop in Discord. I wrote a wiki page yesterday on how to install it, that has a little script, a little quick Ubuntu script on how to automatically build the attack range on Ubuntu 18.04 instance. So if you wanted, again, to do this right now on your own, in your own AWS instance, I'll paste that wiki page in there as well. Here you go, Rod.
Oh, yeah. Sure. So Packer is another alternative that you're going to have to use. You're going to need the binary and sort of perform a similar run on installing Packer. And you always need, if you're using, when you're interacting with any cloud vendor, most likely you're going to need their SDK or their CLI. So in this case, as you can see, you're going to need the AWS CLI. and you're gonna have to configure, like Jose said previously, your SSH keys. I actually took the time to put a screenshot exactly where you had to configure the SSH keys. We're gonna see that in a minute, because that for me at first was one of the challenges, because you had to provide the right SSH keys that match with the name of the SSH keys that you register in AWS. If you do not do that, you're not going to be able to communicate with your instances. So it's important sometimes, because of configuration errors, it may look like a network error, or it may look like a hiccup, but it's not. It means you had not placed the SSH keys, the correct SSH keys, within the code, and we'll go over about it in just a few seconds. You may also want to change the Splunk admin password and win password within attack_range.conf. If you're building something that you're going to use for 10-15 minutes, probably you don't have to worry about it. But we have seen cases where, unfortunately, there are people on the internet looking at this, they had put the passwords and access the instances, and you don't want that. You're going to get a nasty alert from the AWS security team, because most likely what they're going to try to do is install either a crypto miner or something. But it is important. We're working on creating random passwords as we build it, but it's something that you want to pay attention to. So next.
Yeah, actually, Rob, before we leave this one, I want to add a little bit of color about why Packer exists in the attack range. So we attack range, we mainly have, again, two modes, which is Vagrant, you build it locally, or Terraform to build it in AWS. The main reason we built Packer was to speed up the build time in AWS or using Terraform. What the Packer mode does is it's no different than Terraform mode. In the end result, you get the same exact environment, but the difference is the process, how it does that. The Terraform mode, it spins up all the machines, and then it uses Ansible to provision them. Packer mode, what it does is it builds AMIs, provisions the AMIs, and then spins them up. So the AMIs are already pre-built. Why do we introduce Packer? Packer makes it really fast to consistently be destroying and creating ranges. Because the first time around, you're building an AMI, it takes about the same time as using Terraform mode, but any other subsequent destroy and create, it's about a minute long. By the way, the attack range takes about 15 minutes in total for it to fully come up. And so again, we introduced it mainly for that kind of workflow where you're continuously, you test something, you build it up, and then you destroy it, and then you build it up again, destroy it. One caveat here is if anything gets changed, like if you change anything on the configuration file in attackrange.conf, then Packer will have to rebuild those AMIs since the environment now has changed essentially. But besides that, this is why this mode exists. Yeah.
Cool. Okay, so here's the comment that let me bring back the comment that I was making. What you see here is where you're gonna place your creds. This is very, very important. When you clone the repo for the attack range, there's specifically a file which you're gonna have to modify to your convenience. You're doing this because you're gonna have to tell the attack range, okay, maybe I don't need Kali. Maybe I just need the Splunk server that brings Caldera and Atomic Red Team. Obviously, you need a host where you're gonna execute these attacks. So that will be either a client or either a server. And then in order for you to communicate with those instances, you're gonna need your keys. The keys, where are the keys? The keys are registered, and you can create it. There are two ways of doing it. AWS can generate them for you, or you can generate them yourself and upload them to AWS. So specifically under range settings, there is key_name equals That's where your public AWS key name, I repeat, name is where it goes. So even though you see the .pub extension, I named that exactly the same when I registered and uploaded my keys to AWS. So it's important for you to understand that if it doesn't match, you're gonna get errors. It's gonna give you, oh, I couldn't SSH into X host. Under private underscore key underscore path, you can see where I store my actual private key. And I created that. This is something that I do every time I'm working with cloud environments. I have keys for every single cloud environment. I don't share my keys with different environments, and I just do this. And usually, sometimes I even destroy the keys as I create new environments. So remember, if you look at this, the screenshot on the top right, you will be able to see the structure of the files and directories when you clone the repository. And on the left is when you either cat or nano or vim attack underscore range.conf. So remember that. Next up, please. Here, so it is even clearer. There is, like I said before, in order not to confuse, even though it has dot and extension, it is exactly the same name. So you had to go into your what I call the GUI, right, the console, and then you had to register your key pairs. And in your key pairs, I generated my own, I uploaded it and named it, and that's the name that goes into the configuration. Next up, please. Okay, so what we're about to see here, and we're getting close to the point where we're going to start getting hands-on with this, is important things that you had to look within attack underscore attack range configuration. So the administrator password, as you can see, is pretty standard. Remember the comment I said, you should change those passwords to something that you remember, and it is not easy guessable. Otherwise, I promise you, if you leave these things overnight, they'll probably be accessed and probably compromised. Remember, when we use infrastructure as code, one of the premises of infrastructure as code is ephemeral. It means it doesn't stay there. It gets used for what it needs to be used, and it gets destroyed. That's it. These are not instances that are meant to stay there, unless, of course, you want to keep them. But because it's flexible and it's scalable, you don't want to you want to use them for when you need to use them. I understand it takes 10-15 minutes, but if you save your configurations, and once you get acquainted with how to use it, you can build it anytime you want. So some of the things that you had to look is, for example, the Windows settings is the username will be administrator. The password is specified there. It tells you where to download the applications. For example, you can see clearly what is downloading the Splunk forwarder. It tells you, for example, the win sysmon template. Like I said before, we're using the template for sysmon configuration, which is one of the tightest and highest on auditing, and obviously producing verbosity on locks, and that gets done for you. You don't have to do. I remember when I used to have to download an ISO, then I had to apply this again over and over and over. It is tiring. In this case, you just had to configure what, even locally, you just have to configure what instances you want. It will download it, it will build it, and it will be ready to go. And one more thing, as you can see here, the button, if you wanted to stop, for example, enterprise security, 0 is not, 1 is yes. So let's move on to the next one. So here's, before we get onto this is where you tell this software what you want. So for example, I want a Phantom server, I need to place 1 in it. I want a domain controller, by default there will be a 1. If you don't want it, you place 0. If you want a Windows server, you place 1 or 0 if you want it or not. Kali machine, the same thing. So remember, you got to go to attack_rage.conf, and that is where you modify the environment that you want to build. So if you do not modify this, by default, you will get a domain controller and a Splunk server. That's pretty much what you will get. You will not get the Kali or the Phantom. So these are things that you have to look at before you execute. Next up. So let's talk a little bit of adversarial simulation before we go into our hands-on exercises. The reason, again, we did this was basically to get ground truth about replication of attacks. And in this case, we have selected two frameworks. One is Caldera, obviously developed by MITRE, which MITRE is the leading company in TTP nomenclature. MITRE is the creator of attack framework, creator of holder of the CVE database, and many other information security tool techniques and procedures nomenclature. So what we want to do is basically use this industry accepted framework nomenclature, replicate it operationally in actions. And these actions are usually attributed to a specific adversary, right? So what we want to do is conceptually is apply this, replicate this attacks into a sample host. Now the sample host, and this is something that I mentioned when we started this presentation, should be a golden image. What is a golden image? A golden image is an ISO, or can be a container depending on the environment you are, a virtual machine, that, or even a bare metal, if you have to, that represents your InfoSec policy, posture, and hardened procedures. So for example, if I am in a company and I want to make sure that when I test this attacks, they give the results, give me a real information on how my enterprise, how my company will be affected if this attack was performed. I had to do this on a golden image. So in order to create a golden image, most likely you're gonna have to go to your IT department or SecOps department. It depends upon your organization, and you're gonna have to ask. And most of you who have worked on an enterprise or work on an enterprise, you know that when you're delivered an asset, being a laptop, being a workstation, or being a server, there is a configuration, there is an inventory, there's a number of tools that are placed in it that were purchased, maintained, and managed by your organization. So if you want to make this truly closer to what the real thing will be, you want to do this on a golden image. Next up. And obviously the reason why you want to do this is because it will represent your attack surface. It will test your attack telemetry. It will test your incident response rules. It will validate your defense rules. Many times you can apply your own defense procedures into these environments and see how well you're doing, including, for example, if you're looking at how to prevent escalation of privileges, do you have the right GPOs in place in order to prevent this? Our range cannot give you that, because our range basically gives you the benchmark where to apply these defense procedures, where to apply these defense measures that apply only to your organization. So this is important for you to understand that it's almost like we're giving you the dough. You have to make the bread. You had to work on this, and the more detailed, the more customized you make it according to your own organization, the much better for you, in order to gauge the resilience of your organization. So in some cases, for example, this also may help for I had some analysts that have there are certain environments, for example, that you cannot pen test or that you cannot use specific attacks. In this type of environments, this type of tools come in handy because, yeah, you cannot attack them, but you could simulate as close as you can. So this is a great tool for blue teamers. Next up. And then right before we go into the hands-on stuff, it is important for us to disclose to you that adversary simulation does not prevent 0 days. Remember, we're replicating stuff that's already published. We're replicating stuff that is available. This, however, if you get, for example, an exploit for exploit DB that you can download, for example, or you can opt the Metasploit via Kali, you can test right away something that's been published. And you can also do exploit development as well. If you had that sort of capability, that sort of knowledge or skills in your environment. This does not replace pen testing or bug bounty or red teaming. It's an additional tool that you can use, and it would definitely, if I want, in my years of blue teaming, this was very important, because if you don't have the resources, you cannot have a pen test, you don't have the skills, this will give you a little bit of a visibility of what will happen. And of course, remember this, many times, if you turn off your EDR or AV, you know, this is an accuracy, a question of accuracy, how accurate this is, because many times, because I'm sure many of you heard the word golden image and say, well, my golden image has CrowdStrike, or it has Stadium, or it has Carbon Black. Okay, well, sometimes you may have to turn this off in order to see the extent of damage. So this is something that actually question the adversary replication tools. And again, these tools partially depict sophisticated adversary actions. This is not the entire picture. This is simply an additional tool. So next up. Okay, so included adversary simulation engines. We have Caldera developed by MITRE, and we'll see in a minute how to use Caldera. Caldera has an agent. This agent is installed at the host, and then you have to choose a number of profiles to execute, and then you get results. Next up. And we included Atomic Red Team. Atomic Red Team has what we call the Atomics. The Atomics are basically replication heavily endpoint based TTPs, which are based on, are actually categorized within MITRE ATT&CK framework. So if you for example are within an organization that will tell you, hey, I need you to give me a report, how we would do if the following techniques are performed against us. This is a great reference. This is a pretty easy to test and to record and analyze. Next up. So here's, I was mentioning that the MITRE ATT&CK framework keeps expanding and expanding. Obviously, we can possibly think that we can include the entire universe of attacks. And once, I always tell people that once an attack has been recorded, categorized, and named, it likely will not be repeated by the same actor, because obviously, what would you do that? You will get caught. But that doesn't mean we cannot learn from these techniques. That doesn't mean we cannot have an idea of what they have tried to do and be prepared for it. So next up. All right. So here's what we're gonna give you a run on the actually how to build it, run it. We're gonna show to basically handhold it, how you operate it, and then we're going to go into the real deal. So what we want to show now is you're going to build it, we're going to perform an attack simulation, we're going to search it, we're going to destroy it, or you can stop it or resume it. So let's go ahead and next. So here's the commands. I'm going to pause for a second. These are the commands, the basic commands that you need. You can always, and Jose will probably will go over it in a minute. You always obviously remember you clone it, you build the virtual environment on Python 3 if applicable. You execute pip, get your libraries, get your binaries, modify your attack conf, use the mode Terraform at cloud, or use Vagrant if local, and then basically what you're going to do is execute the attack_range.py, and that you have to tell it, okay, if I'm using a local, then the mode or -m will be Vagrant. If I'm using the cloud, the mode will be Terraform, right? So the first command that you're seeing there is how to build it. The second command, and this is also very important because usually, you know, it's exciting to build all this, but it's also important to test it. You had to do the sequence, the appropriate sequence, which is basically you had to tell it, okay, what mode am I using? Am I using the cloud or am I using local? And then action -A. What am I doing? Am I building it? Am I destroying it? Or am I simulating? So in this case, if I'm performing a simulation, it would be -A, simulate, and then SD, which is the simulation technique. And it will give you, then you can place remember when we were looking at the MITRE attack matrix, you can actually pick up numbers from there, not all of them. There isn't a specific number of atomics. They don't reproduce the entire gamut of the MITRE attack, but a lot of them. I have to say the coverage is pretty good to get you started. And then finally, you need to tell the attacker, the target, sorry, that the target will show once you finish building, and I will show you that in a second. Once you finish building the attack range environment, there will be a printout that tells you the name of the machine and the IP address, so you're ready to interact with it. Jose, I'm not sure if you want to chime on this one or.
Yeah, definitely. I noted this in Discord, but the goal is at the end of this, I'll walk everyone through building one from scratch on an environment, and
looks like we had another issue with Comcast, but that's fine. I can pick it up with it. Don't worry about it. We're gonna walk you through this, and we're gonna make sure that we cover the what you need to know in order to build it from the scratch and operate on it. Let's see. So the other two things that are important, what we gave Jose some time to come back, is you want to destroy it. If you are, and I'm telling you this is if this is a Terraform, for example, if you're in a company and you know you're in a tight budget, and you know it may cost a little bit if you leave a domain controller, a Windows server, a client machine, Windows client for a month or so. They may, you know, it may cost a lot of money. So you want to destroy it, and in order to destroy it, you had to go into you had to execute Python attack_range .py. And hold on, looks like he's. Can you hear me, Jose?
yeah, I'm back. Sorry about that.
Okay, cool. Okay, so I was actually going through the how the process of destroying it and how it is important to understand that when you are in the cloud, and because there also one of the things that you can modify, by the way, is where are you downloading these ISOs from. So as long as these things are static, you can always rebuild them anytime you want. And there's one thing also that as a researcher I can tell you, there might be issues with licensing depending on what you are loading to the cloud. And also, I know it's not easy at times. Usually when you are doing exploitation research, you may want to work with vulnerable machines, and there are a lot of scanners, and there are mitigation, I guess, technologies in place that may not allow you to do that. You may want to do that locally. Not sure if you want to chime in now, Jose.
Yeah, yeah. So again, probably want to end up building these things locally if you're only testing specific, like one specific attack. And to Rod's point, if also when you built this on AWS, what the attack engine is gonna end up doing is it's gonna attach the way it knows what it builds itself. It's gonna attach its name, like attack range something, and your vagrant key, right? So the name of the instance plus your SSH key, your vagrant key. Your SSH key is what it filters by when it lists what servers are available, and also when you go destroy, because it's using Terraform in the hood, it's going to have a really good, it's going to know what state your environment is built under, so it knows exactly what to destroy afterwards. And essentially, when you do destroy, you basically cleans out everything. When the range is building on Terraform, it's building on its own VPC, so it will never conflict with whatever you have running also on your account. It makes it really, really easy to run. Like again, if you're running some other application, I mean, this is your own personal AWS, or you're using even your company's AWS account. You don't have to create an account to run the range. It's going to run everything its own unique, separate VPC with its own subnets, its own route gateway, so on and so forth.
Which is pretty convenient, because that if you're new to cloud environments, this is it can be a pain to configure all this. It would take you some time to get there, in all honesty. Let's move on, please. Okay, so this is what I had mentioned before. This is what you would see, and now we're finally entering on the walkthrough before we get on the hands-on, and we'll give you the SSH keys, and you go away and play with it. So what you see below is the command that I used to build it, and what you see on top is the last printout. The last printout basically says you have this EC2. Obviously, we're using Amazon EC2, and this is what you have. In this case, I configure a Kali, I configure a Splunk server, which is where Caldera is, by the way, on port 8888, and then I configure a Windows domain controller. If you look on the right, you see the status, and most importantly, you see the IP address, because at one point you may want to access these things, right? So next, please. Here's a simulation. Remember what I told you about the target machines? That you had the name. Remember the last screenshot I showed you? Because those are the names of your machines, unless you decide to change them. Those are the names of your machines. So when you look at that printout, you may have to make a mental note of the IP addresses and the names. So when you perform the simulation, you will know the target that you're performing it against. So as we said before, in the actual following the wiki, you basically had to execute attack_range.py. In this case, the mode is Terraform. The action is to simulate, and the target in this case is the domain controller. And then the simulation technique is T10103, which is credential dumping. Also, you can also, if in case, because what happens sometimes when you're doing all these attacks, you get these very large printouts. If you do Python space attack_range.py space -lm, will give you all the list of machines again. So we'll list the IP addresses and the name of the machines. As you can see in this printout, we have been able to successfully execute T1003, and it tells you what host. You can see it below. It tells you, yeah, I executed an atomic red team, and that is the actual result. Next up. And now the nice part of this, which is we have where our team has done an amazing job building dashboards. So basically, it will tell you exactly what simulations have you run, what type of techniques have you run, and then you can delve into this. You can actually look at the indexes I previously mentioned and actually found the data from the attacks that you executed. So what we're looking at right there is a standard dashboard that you're gonna get once you build the attack range. Remember, Splunk, the Splunk where the you're downloading is free. You don't have to pay for any of this. And you have included with it, you have ASX, you have Stream, you have Security Essentials, you have ES content updates, the attack range reporting, which is what we're looking at, and of course the search and reporting. Not sure if Jose wants to talk a little bit about ASX, but this is what you'll be looking at once you start executing attacks. Next up. There. As now that we have executed at the command line base the atomic, now we can take a look. What you're looking at here is a table that is under that dashboard that you just saw. So in this table, you have the atomic test that was performed. As you can see, it was a PowerShell Mimikatz and GSecDom. On the right side of it is the host name. Remember that we built a domain controller, right? So we're putting all together now. The MITRE ID, which is T1003, is we knew it was credential dumping. It tells you exactly where we got this from. It tells you the tactic, credential access, the technique, and then the test name. So that way you have a reference. Okay, these are the things I had tested. So we go from A, execute the attack, to B, which is, okay, what I executed, what is it recorded, and we can delve even more. Next up. We can even look. Remember the indexes I mentioned at one point? Look at this. Well, you can go in the index, and it will tell you what the technique was that was executed, and the event tells you the time that it was executed, the host that it was executed, the specific attack that was done, and the number of times that it was done. So this is for an analyst. If you're trying to produce a report or how we're doing against the let's say you try to choose a column within the attack matrix from MITRE, this makes it way easier. Next up. All right, so we're going to go back to Splunk in a little bit, but I wanted to show you a little bit also of the frameworks that we included. You already saw the attack atomic red team that it's by default included in it, but we also have by default Caldera. Caldera is obviously developed by MITRE. They are the original creators of this nomenclature, along obviously with a consensus in the industry, but basically this is what we are following nowadays. And I wanted to give you a little view of how to use Caldera. When you install the environment, automatically there will be a Caldera agent at the host that you choose to build. So what I'm showing you there is an agent. Look how it tells you what the host is, right? This is the host win-DC. Remember, we specify all this before we built it. So this is important. This is why we decided to go from A to Z, showing you step by step. And you can have your C2 connection via HTTP or TCP. In this case, this is a TCP. It tells you what type of privilege the agent is running at. This is important if you're doing tests, obviously, and the PID, the process ID. Next up. So now that I have my agent, running. Remember, you cannot run Caldera if you don't have an agent at the host. You need to have an agent at the host. Sometimes I refer to this uh, attack simulation frameworks. They remind me of old school banking Trojans, like a SpyEye or SUSE or Andorad, stuff like that. It's basically you have a C2 panel, and then you have an agent, and then you execute actions on it. So in this case, we're doing this in a much more, I guess, defensive focused way. So in this case, for you to basically apply this, first, I repeat, you had to have a agent at the host that you decided to build when you modify attack_rage.conf. And then once you log in into Caldera, which is the same IP address of the Splunk server, but the port, instead of being 8,000, that's the port for Splunk, 8,000, the port for Caldera is 8888. So once you are logged in and you check out that your agent is working, if the agent is not working, you will see it in red. The PID will show in red. So that means you may probably have to reinstall the agent or deploy another agent. And the way to do that is basically if you look at the menu, basically it will give you a code, and you're going to have to access directly your host. So if we were to access directly our host, we had to RDP in one of the IP addresses that you saw in the printout. So you are going to need an RDP client. It's a full-blown machine, by the way, a full-blown Windows machine. You can access it, you can show whatever you want in it, and you will have to basically execute their code in order to redeploy the actual agent. So once I have my agent working, now I want an adversary profile. This adversarial profiles will tell me, what is it that I'm looking for? Collection, discovery, enumerate. They have several applicable profiles of actions of abilities. They call it abilities that you can execute on the host once you have a running agent. And this is an example of it. Next up. In this case, I decided to use the discovery profile. And what you're about to see here is basically me executing a discovery profile of actions on a Windows host. This Windows host, as you know, is the win-DC. And then I name my test. So once you execute it, as you can see on the right, it goes by time and it tells you exactly what it's using. You can see what things have been on green, have been identified, for example, identify local users, identify active user. So the green ones are the things that were able to be achieved, and the other ones were not, right? So in the top part, you have the percentage of the entire simulation. So it tells you, okay, these are the actions that I'm performing, and this is how long I had to go in order to complete it, to say it in a certain way. So next up. And then this is a little bit of the extra work, but you can do this as well. Once you, if we can go back for a second to the last slide, please. If you look onto the left menu, at one point, once you finish, and depending on the settings that you have, you can download the report. The report, you see there's a green icon there. And once you download the report will be a CSV file. So now we can move on to the next slide. And as we see the next line, what I did is basically uploaded the report. We're trying to find ways to automate this. We had some hiccups with some of the releases from Caldera. Sometimes the code changes, and we're still trying to figure out pinpoint where specifically what the report is stored. Look, it's stored in memory. We're not able to pull it, but we're working on it. So that way we automatically import this report. And all what I did is that you download it, you go to settings, add data, you source type is CSV, and then I basically Splunk will parse it, and from there I created a table. And then in this table you can see it tells you what the privileges are. If you look at the left, this is elevated or this user. It tells you the platform. It tells you the host. It tells you what was done. It tells you the ability detected. It tells you the ability name. So basically, we have a full report of what happened, and it tells you, look, if you look to the right, you can see a display name. You see Win-DC NT authority system. So we can't get more granular than this. This is pretty much showing you what happened and what went from A to Z, from the creation of the environment, replication of the attack, recording of what happened. So next up. And of course, for those who like to play with exploitation, you can always Kali. So I put this for the sake of it. I put this so you guys can see. This is what you see here is me exploiting the Windows server using Metasploit. But of course, this opens the doors, because once you have Kali, you can do whatever you want. You can install, you can download, you can use. For example, I'm not sure if some of you guys remember, there was a recent Windows privilege escalation exploit that had to do with a print process, and you had to install the new version of Empire. You can do all that here. You can do all that here, and then you can record it at the Splunk level. Will be recorded because it's audited already by a sysmon. So there are many things. The possibilities for you are quite a bit extensive, because now you have the freedom to test all this. You don't have to do this. If you're in an enterprise where there are so many constraints about what you can do and what you cannot do, this is done on a private VPC in the cloud. The tools are there already. You don't have to take hours and hours configuring, downloading stuff. So this is the wonder of this tool. And now we can replicate attacks, build exploitation, test new malware, ransomware, whatever you want. So I wanted to show you all the possibilities that you can do with this tool. Also, and we're not touching really on this today, but you can actually add Phantom, and with Phantom you can actually add responses to these attacks. That will be something that we will present in the future. And I think with this, we're ready to go. Let's see what's next. Oh, this I think this is my basically a slide where what I just executed, by the way, you can see I named when I created the payload. When I created the payload for Metasploit, I basically named it attack range.exe, and there is the data that comes via syslog. I did this on purpose, obviously, to show a proof of concept that how even if you're not just replicating adversarial simulation techniques and you are doing your own attacks, you can still find the data at the name host. And with that, I think we are lap time. So Jose, take it away.
Thank you, Rod. Yeah, so yeah, let's start playing with this thing. I'm sure everybody's excited to just get their hands on it. Really quickly, I just have three quick slides. So we have some pre-built lab environments, and then I'm also going to build one live here, and you can follow along building it on your own. If you're going to follow along, you're going to need an AWS account. If you don't have one, go build one while you're listening to the last 3 slides if you can. Sorry, go sign up for it. But at a really high level, the lab that we will be providing you or will be building is essentially, we're going to be first building up an instance of, I'm calling, because I'm not creative with names here, the attack range controller. That's what we're actually going to use to build our range and control it. You can obviously do this on your local machine if you're doing it on your own. But for the sake of the lab, I just wanted everybody to jump on one machine that has everything out of the box for them going. So you'll be SSHing into this controller, and then from this controller, you can launch attacks to the Windows domain controller instance that's already built. Or again, you can be building these if you're following along. You can also SSH into Kali Linux. Again, I'll give the credentials out in a second. And you can also reach via RDP, as Rod mentioned earlier. You can grab the RDP client for Mac if you're using Mac OS, or you can just use the Windows remote desktop, the remote desktop client as well. For Linux, I think ITPC works or ITPX. I don't remember, but yeah, just grab it. Your favorite.
Are you going to provide a list and assign it to each person that's in as an attendee, or how are you going to handle the access?
My request was just have whomever wants to have the pre-built instance going to DM me, and then I'll assign them a team.
Oh, okay. Yeah, make sure you guys do that in. Yeah, make sure you do that in Discord, guys.
Yes. DM me in Discord. I have a slide on the Discord instructions and my username in a second, so you don't get lost there. But Joseph, great point. Thank you. So yeah, this is a high-level environment. You can reach Splunk on HTTP 8000. Not listed here. You can reach Caldera on the same IP, but on port 8888. So on the ranges that I'll be providing in a minute, here's what's done for you. We installed the OS dependencies. We've already configured Terraform. We've already pre-configured the attack-range.conf file, and we've already built a range. If you can always destroy and rebuild if you wanted to see what the process looks like, but just FYI, this is already done for you. Again, how to get started? Discord channel, DM me at div. I'll be handing off credentials in the next few minutes. And again, once you get those credentials, the first step is you'll be able to SSH into the domain controller. You can log into Splunk, check out the results. Again, I'll give you credentials for all these NIPs for your respective team, and run detections off of Splunk, enterprise security content updates. You can play with more complex attacks, et cetera, et cetera. So right now, go to Discord, message me. I'm gonna pause this video right here so I can start providing credentials back out, and then in 2 minutes I'm gonna start building a range from scratch if you're following along. Okay, so
all right,
5 minutes for everybody to get started.
Sounds awesome. Thank you.
Sounds good. Perfect. Thank you, Joseph.
Yeah, no problem. So we got 62 people in as attendees. So attendees, head over to Discord. Make sure you DM, direct message. They'll do it in Chan. D1V, and he will get you an instance set up.
So full disclosure, there's about we're gonna try to cap about 10 individuals per shared environment, per lab that we're heading out here. So just FYI. That didn't. So Dragon Cell here. I'm gonna share off credentials with you. I realize that copy and pasting from Google Sheets doesn't pretty print things in Discord. So I'll give you both a screenshot and the text file, because who likes to copy and paste from screenshots? All right, I have DM'd ranges to most of our credentials to those of you who have messaged me. The rest who are following along, I will let me get my my terminal here ready so we can start building one from scratch. Again, we're assuming that you're already starting with an AWS account. If you don't have one, please go create one. We'll get started in just one more minute here.
Jose, you're going to start from the scratch, or you're going to show the built-up environment?
I'm gonna start from scratch, Rod. I'm gonna
Okay,
build,
cool.
yeah, I'm gonna build the controller and everything from scratch.
That's
Yeah.
great. You should go over the attack, the conf thing, attack_range conf, and so they can see it. And
Absolutely, good point. Good point. And again, I'm also gonna be on the Slack here. Oh, hold on, I'm still getting DMs for labs, so bear with me. Now, you know what? I have to send out the SSH keys as well to all those who are requesting labs. So let me get you those right now. I realize that I'm giving you a picture of the of the actual domain, the actual IPs, but not the SSH key. Yeah, happy Fontaine. Sorry, thank you. I'll paste the password right now, man. Yeah, I know they're kind of annoying to copy and paste from or copy from an image, right? Here we go. All right. I think I think most of everyone I replied back to the of DM me. You should have a range. Let's get started of building. Whomever's following along to building our own. So let me start sharing my Firefox again here. You should be seeing AWS console. Can anybody, Rod, can you scream at me and let me know if
Yeah,
you're not?
I can see it. It's not full screen, but
Yeah, a little better.
yeah, that's much better. There you go.
Sweet. Okay, so first thing we're gonna do here is we're gonna build our controller. Again, if you remember from the presentation here, we're gonna build this giant purple box first, and then we'll get the range started on this controller. For the most part, I'm using Ubuntu 18.04 images, but any Linux image should work just fine. Here, so I'm gonna go with the Ubuntu 18.04 LTS. And again, because all of this machine is gonna do is just allow us to install a command line interface and run commands in it. We really don't need a whole lot of horsepower in it. The free tier T2 micro should be just fine. So let's proceed with this one. Actually, so really what we want to do here is on the security group, again, make sure you restrict this to your IP address. I will leave it open for the sake of the example here. But just, again, just make sure you restrict this to your own environment. I'm going to destroy it right after this example, so I don't really mind too much. But if you're going to keep this around for a bit, you want to restrict that out. Storage doesn't really matter. You know, again, we're going to be installing a CLI here, so the 8 gigs, the standard works just fine. I'm going to call this, then I'm going to give it a name of attack range controller 6, because we already have we have 5 pre-built labs, so this is going to be my 6. And again, set 2422, perfect, open to the world. That way I can share this if anybody else DMs us later and asking for another environment, and launch. Now, here's the part where, again, it starts getting not necessarily tricky, but just make sure. I'm going to create a key pair for this. And this is the same key pair we're going to use for the range, so just FYI. And I'm going to call this key pair attack range team 6. Again, whomever's the lucky one who joins and asks for another DM for another environment, I'll give them these keys. So got a new set of keys here. Boom. I'm gonna go ahead and download the key pair and then launch the instance. Now, while this instance is coming up, I am going to grab the public IP. Let me switch over to my terminal. Bear with me here. Can everyone see my terminal?
Yeah.
Sweet. So thank you, Rob, for confirming. I'm, for the sake of argument, I'm putting all of my keys in this Jungle folder for. So I downloaded the key earlier that we just generated from AWS, attack range team 6.pen. I put it here, and I'm going to start SSHing into this instance. So I'll pass it the key. There we go. And username Ubuntu, and then the IP address. It's going to be the IP address of the public IP address of the machine, which I thought I copied, but let me make sure. So this is the machine the controller we just spun up. There we go. Oh, I forgot to change permissions on my SSH key. Let me just fix that. It needs to be read only, otherwise SSH won't want to use it. All right, so now we got a very clean, brand new Ubuntu machine. First thing we want to do here, again, this is going to be the machine we install the attack range on. We're going to run an update. It'll take a minute. Let's grab the latest packages. And then the next thing we want to do is start installing some OS dependencies. A lot of this, again, gets covered by that Ubuntu installation script. Specifically, we're going to go ahead and install, we need Python 3 dev. We need the header files from that. We need Python 3. I'm just going to bring it on zip. We're going to need pip, Python pip. We're going to need the AWS CLI and the Python virtual environment. There you go. It's going to take a minute since those Python headers are not small. I think this whole thing is about 300 megs total packages we're bringing them. If you have any questions as you're following along, I'm in Discord on the track 1H. Just ask away. I haven't checked in a few minutes, so while this is going, I'm going to go ahead and check it. Yeah, Cactus, yes. No, wait, Cactus, I did get you the SSH keys, I hope. Pretty sure I did. Just double check. Oh, Steph, welcome. Steph, give me 2 seconds. Let me just give him a set of credentials. We'll continue. 2 seconds here. Also, it gives everybody a little bit of time to catch up if you haven't spun up the server, SSH in, and install the packages. Go for it now. Okay, so let's keep going. So once we have our prerequisites installed, let's go grab our OS dependencies installed. Let's go grab Terraform. So I literally just wget the Terraform binary right from them. And the reason we installed unzip is just to unzip this little file here. There's probably 100 better ways to do this, by the way, and this is very easy to script out like I shared on the wiki. But again, for the sake of the workshop, I'm doing everything manually. So I'll just move Terraform onto user local bin, so everybody can use it. Obviously, we can't write to this unless it's root. And then we're pretty much ready here to start our setup of attack range. We got all the OS stuff out of the way, so we're gonna git clone attack range right from GitHub. Right? And then I'm currently on the attack range project. The next thing we're gonna do is, again, we're gonna go to Terraform, and let's just Terraform init. All of these, we basically started the configuration at this point of Terraform, since we got the whole OS of prerequisites out the way. So if you're following along, if you want to follow a wiki page, that's the wiki page to follow, the Terraform configuration wiki page. So we're gonna go ahead and Terraform init. Like I mentioned earlier, this goes ahead and downloads the different plugins that we're gonna be using under the hood for Terraform to build the environment. And that's done. Next here is, let's create a virtual environment so we can install the project dependencies. So to create a virtual environment, you just virtual env, pass it the Python version you want to run. This is one of my favorite things, honestly, for Python, that you can separate whatever's happening on your project away from your OS. If you ever had the experience of ruining your OS as Python, like I've had in the past in Debian, that's something that you may never come back from. So this is a good practice. So I just created a virtual environment called VM. I'm gonna go ahead now and activate it, which means that now I am, actually, if I do which Python, you can see what's gonna happen here. My pip, which pip is right now pointing to user bin, which is my systems pip. But the moment that I activate this environment, if I can type, and I do which pip, now pip is the pip that we installed in that environment. So now I can do this fancy thing here, pip install requirements, which actually it's all the actual libraries that attack range depends on for Python. So like things like Ansible, which is what we're using to orchestrate the builds under the hood, and a bunch of stuff. This is going to take a minute. So let it run there. again, this has a bunch of Python dependencies. So we're all done. All of our dependencies have been installed. Now, the next steps, again, I'm just doing this for quality of life. I'm going to change my host name on this machine. I'm going to call it the attack range controller 6. And then the next thing we need to do, which this machine doesn't have right now, is the SSH keys. The SSH keys that we downloaded earlier from AWS. And this machine is going to need it because from this machine, we're going to, when Ansible's running, it's going to actually SSH in and start building the environment. It's going to split my terminal here and go to the key just to make sure I can look at it. Of course, I'm going to display my private key here for the world. Obviously, this private key is going to live about the life of this event, so I don't mind. Here we go. So I copied my key over. Again, SSH does not like keys that are readable by the world. I'm going to make it just readable to my user. This chmod that changing its permission. And the next step here is AWS configure. We need to configure AWS so we can actually operate Terraform. And it's asking me for a key ID. So I'm going to go ahead and flick back to my browser and create a key on AWS. Give me 1 second. Let me share Firefox again. So everybody should be seeing my Firefox now. So I am going to create a key, an API key, so we can actually build the range with Terraform. So I'll go to IAM, Identity Management. And here's a little bit of a tricky part. Today, we don't have necessarily a good set of policies to assign for AWS. The range uses a lot of components under the hood for AWS. So I hate to say this, but just give it admin rights for now. This is something we definitely want to post eventually on the wiki, where we get very specific as to what roles you're providing your AWS user. But for now, just go full blown admin to avoid any potential issues. I'm going to call this attack range team 6. This user, again, a programmatic access. We're looking for the access key and secret. And I already have pre-built a group just with like full admin rights. Just administrative access is the attached policy. As long as I think it has AC2 admin, it should be okay. Doesn't need a name. I just need credentials. Created a user. Live is good. I have a key. I have a user key here. Sweet. So this is what I'm going to paste over. It needs the secret. I'm going to paste the secret over as well. My region, in this case, I'm building on US East 2. One big thing of importance is make sure whatever region you set, you created your SSH key under that region. Earlier back, I should have pointed that out, but we're working on US East 2. And then also when you configure attack range, you see it in a second. When I jump into a configuration file, you want to set your region in there very explicitly. Otherwise, you're going to get errors. Okay, so the AWS configured region needs to match the attack range configured region, as well as the region your key is in. So now that we configured AWS, all we're missing is just configuring the attack range, and we'll spend a minute here. I kind of want to walk through. I want to walk through this config. So first things first. The key name. Oh, I just realized I've been in Firefox this entire time. I'm so sorry. Let me go back here. Yeah, so just going back here for a second. Basically copied and pasted SSH over, and then I ran AWS configured. You haven't seen it to configure region. So next step here is attackrange.conf. And here first, the name of the key here needs to match the key that we created in AWS. So attack range 6. I'm just going to flip really quickly back to AWS here. If we go to the EC2 service, and we go to key pairs. You see that there is an attack range team 6 key, and this name specifically needs to match the name that we provided over here. The whitelist, again, highly, highly recommend if you're building this on your own, you restrict it to your own IP. Attack ranges get attack. Build them up actually by bots or third parties. And also make sure, we'll do this in a second, but make sure you change the passwords. I know that this already landed in some more list, and like I said, like Rob mentioned earlier, if you leave your range up and you don't change your IP address, your whitelist here and your default password, you're probably going to lend your range to some Bitcoin miner, or somebody's going to essentially use it for something else.
Yeah, we already got some instances of AWS sending us messages that our stuff was accessed. So remember that.
Yeah. I'm sharing this out of experience. Not don't make the same mistakes I did, basically, right? So again, I changed up the region to point to US East, just like where my keys are and where I configure AWS at. And I'm going to generate a quick password here. Give me 1 second. And then measure. This is one of the reasons I love Vim. Little neat Vim click. Percentage S allows you to run regex, like said, find and replace. So I'm going to find and replace every instance of the word attack. I like attack range, which is the password we use by default, with bang at the end, with this generated random password that I just got. And boom, that went through the entire file and changed. I like the attack range. So the default password is no more. Let me just grab this one and set it aside. And then continuing here, our configuration. So we configured the region. I've already saved the SSH key under this file. If you recall earlier, this is the file I ended up editing. You can obviously put the SSH key in any other location you want, right? Like let's say you want to use, you have under the private key path, some other key because you're using this server that you're building up for something else. You can always pass it another path, right? Just FYI. And I'm not going to change even though I said it like 10 times to change it, I'm not going to change it just because, again, we've been sharing this ranges for everybody to play on. So I want to keep it open just for the sake of this lab. Continuing here on the configuration of the range or the config file. Again, I set a replace of the default password, so the Splunk password change and all the other ones, but cool thing about the range is it allows you to configure all kinds of stuff like what Splunk version you want to install. We grab all the apps instead of from Splunk base. We grab and run from an S3 bucket. Splunk base doesn't have an API today, so this makes it really easy to just grab apps and also freeze the version that we're using. But if you wanted to roll your own app into Splunk, you can set your own S3 bucket and put the app in it as long as you pass the right name in here.
A question, Jose, are we leaving the binaries for everybody?
Are we leaving this bucket is open to the world? So
okay,
yes, Rod. Sorry, I'm not sure if that was the question.
Well, meaning if they want the binaries, for example, for the ISOs and stuff like that, because I know things changed pretty quick. There was a gentleman asking a question about Caldera. We had to do some adjustments because as the versions change, it affects our configuration. So that my question is, we're trying to provide stability on the lab itself. So we're leaving them there. Am I correct?
Yes, that's correct. And actually, to further that point, we fork Atomic Red Team. We're not using Atomic Red Team as it is on the project live. We keep a fork just for stability purposes, as you mentioned, and same thing with Caldera. I believe we fork Caldera as well. And again, this is to avoid like any potential upstream changes, breaking the attack range build process. We typically update any fork we have on a monthly cadence. Sometimes that happens to be 2 months, but we usually try to avoid, slipping more than 2 months away from whatever the project's head is. And again, for the Splunk apps, we just keep a copy of them on this open S3 bucket. Again, all of these are completely free and available off the Splunk-based marketplace, but they don't offer an API, so it's just much easier to just grab them off of a bucket. Few more little notes here. If you heard before about the bots data set and some other cool work that the specialists do, security specialists at Splunk do, you can have the bots data set pre-built, which means this is a set of a data set that already comes with like pre-built attack scenarios. Then you can install on the range of the Splunk server as it comes up automatically if you wanted to test with data that's already there and available. Good explanation on the right on the README. Again, Phantom server, pretty straightforward. It's going to need the Phantom community username and password if to install other apps and to grab Phantom, since Phantom, I think it is paid for, but there's a free version for it. You still need to log into the community. And then Windows, again, we're also passing the Windows forwarder URL here, right? You can change whatever forwarder you want to, whatever version of forwarder you want to use for Splunk. And Sysmon, another thing that we're doing with Sysmon, and this is again something that just completely bit us as well, was right now we're installing Sysmon right from our S3 bucket, but that's again because we had a situation where version of 11 of Sysmon had a bug. We were downloading it right from Microsoft. Microsoft doesn't provide versions or the previous version of Sysmon, and so you're only always pulling from the latest, and this broke the attack range for about 2 days. So right now we're just kind of freezing. I think we're on version 11.01. They just released 0.02 recently, so we're about one minor release behind on Sysmon. Again, if you want to just download it right into your bucket, this you can just point right to your bucket here. You don't have to use ours. You don't have to trust us. Okay. And then the Sysmon configuration for Taylor Swift. You just pass the file here. I'll show in a second where this file is coming from. It's not very obvious, but we have some pre-built configs for Sysmon already, like the Florian's Roth server and workstation config, Taylor Swift, and also Olaf's Hartons as well. If you want to play with enterprise security, something that you can just turn on. This does require enterprise security downloaded and installed under the apps folder on this project. Again, enterprise security is paid for. It's Splunk SIM, and it does change the way you reach Splunk to use HTTPS instead of HTTP by default. And when you pass it, whatever you put in the folder, make sure the file name matches the file name here. This setting allows you to install the Splunk machine learning toolkit. Again, flip 10 if you want to do some machine learning stuff. This allows you to configure Splunk's data stream processing. So if you wanted to send data out of a DSP, I'm going to jump through this. There's a lot of features in here, but I want to, for the sake of time, I want to focus on the main stuff, which is here the environment configuration. Sorry, the environment. So in the environment configuration, you can, sorry, I jumped around. And so again, you can select Phantom server if you want to build one. If you wanted to build, by default, you build a domain controller, a Windows server, or a Kali machine. In this case, I want to build a Kali machine. So I'm going to go ahead and, I'm going to just set this to 1 as well. And then everything else here is like if you want to change the private IPs when they come up, or I wouldn't recommend you to play too much with this unless you really know what you're doing. But it's all kinds of settings. So like the parameters, like what version of AMI image you want to use, if you want the clients to join the domain. Again, the cloud attack range environment is set up there as well. It's usable. We just don't have any simulation engines for it out of the box. But that's the config file. Again, the parameters we ended up changing were the key. Just going really quickly, let me go back up. The key name and the region in this case, and then the default password. Let's get building. So I mentioned earlier, building takes about 15 minutes. So we likely won't finish the entire building, but I am going to jump into another environment just to show you attack simulation and how that looks. So mode Terraform, because that's what we're prepping for, action, build. And there we go. It throws a message about Vagrant not being there because we never installed it. We're not building this for Vagrant, but let's see if I did everything right. This should just start going. Yep, it looks like at least Terraform was able to start working. So it's now creating all the different pieces in AWS for this range. If we select the VPC, the subnets, the route tables, go. The main controller just, I think the machine's starting to come. If I flip over to Firefox, you're gonna see this stuff come up here. Let me show you what this looks like under AWS. I'm just gonna filter by our key name, which is attack range team 6. And I should be getting machines going. So this isn't terribly wrong.
It takes a little bit.
Yeah.
It takes a little bit.
Let's see here. You know, I must have done something wrong because I don't see the machines coming up. They may be coming up in another region.
You're in Ohio. You're in Ohio. Do you select the east? If you select the east. Okay.
Yeah, US East 2. It's gonna get a minute. It's only around for a minute, so it may not even be. Let's give it a minute. Unless I didn't save. But here, let's just give it a minute. While this is going, I want to show again for the sake of time. I'm gonna jump into another range. While this guy's building. I mean, again, you can run this on your local machine if you're interested, or just let's try and rebuild the current range we shared. You'll see the process, but it does a lot of cool stuff. Like again, it created the instances in this case. It's here. You see it trying to connect to the instances. Actually, I think that's the error. No, there. It's trying to connect to the different instances. Then it runs Ansible to provision it, and then it goes ahead and starts. Like in this case, it's building the domain controller.
We're still looking at the Amazon. You have to switch to the CLI.
Oh, sorry. I have
There you
it.
go.
Yeah. So yeah, you'll see here again. It's going to do all the AWS stuff, bring up the box, then try to connect to it, and you see here trying to connect. This is waiting for the machine to actually come up, and then it'll SSH into the machine, and yes, I can actually. Let me see. Is that a little better? Text-wise. There you go. So it's coming up. You see that's like disable Windows Defender. We disable Windows Defender because sometimes when you're emulating certain stuff, you don't want your input protection to get in the way. But ours, you can go in there and turn it on yourself.
That's actually smaller. If you want to make it a little bigger.
It's actually smaller. So
The one that you had before was better.
was better.
Okay, that's right there.
Is that better?
Yeah. Yeah.
I am. All right. So let's while this range is building here, why don't we go and launch an attack against one? And then we'll figure out where this one landed. I must have made a mistake. I don't know why I'm not seeing it. Me too, propaganda time. But this is got rid of my two monitors a while back. So I have another range. I have another full range running under under another controller. So I'm just gonna SSH into it. This has already been built. Let me just grab the IP address for it, and we can jump right into it. So controller one, I'm going to CV in this case the attack range directory. Again, I'm going to activate my environment that we have under dependency. So which Python should be my environment is Python. And if I run the attack range here, mode Terraform, we're going to, and then I'm going to run list machine flag. So LM means list machines. This is the flag that actually prints out what's running for you. So you'll see in a second in this other terminal when this finishes up, that we get the same printout. By the way, let me make this a little bit bigger, since I know that ideally hasn't been perfectly, like, yeah, the letters were not necessarily perfectly well seen. But go back to this machine. So the one thing I wanted to share here, let's try to launch an attack and see what that looks like. But before we launch the attack, let me browse to the Splunk server and just verify that everything is running. There shouldn't be any attacks in it yet. So let's flip back to Firefox and do that. So HTTP port 8000. That's the IP from the server that I just copied and pasted. And in this case, it's admin. And let me grab the password for this range. 1 second here. Right, got the password in there.
I usually copy the password somewhere once I put it in the config, because then you forget about it.
Yeah. So by default, Raj showed us this earlier, but you see like this nice boot up launcher where like how many simulations was ran, and so on and so forth. If I go to the search and reporting for Splunk here, we'll see there's already a bunch of events been indexed because this range has been running for like 2 or 3 days now. And you see on the source types, already we have Windows event logs, we have network logs from streams like DNS, and some of this is sysmon. And specifically, there's an index that we ship with the range called attack, and that index is what actually has the different attacks. It's now completely empty, so that's what I would expect. So let's flip back and start hammering this range. So Python attack range, mode Terraform, and then in this case action simulate. Right, we're not building in this case, we're simulating. And then we're going to pass it the simulation technique. I'm being lazy in this case, I'm not going to take the whole thing, but that's the shorthand for it, ST. And the simulation technique in this case, let's launch just from the demo credential dumping. And again, just for clarity, what's happening under the hood in a second, I'll show you once the attack runs. But this reference comes from the MITRE technique, but specifically the MITRE technique, e.g., that belongs to an atomic red team. And I'll show again. I'll share in a second where this specifically comes from, so you can see what simulation techniques are available out of the box in the range. But let's try credential dumping. This is going to run, I think, about 17 different ways the credential dumping happens, and then we're going to give it a target. A target machine in this case is the domain controller. If I can copy correct, there we go. Target. Boom. So here we go. It's gonna start launching the attack, and just give it a few seconds. Hoping it works. We could have demo fail. Such is life. I did not give my offering to the demo gods this morning, so under the machine died at some point. That is also possible. Since usually you get like some connection screen right afterwards. Well, this is going. Let me double check what our progress is so far on the other range we've been building. All right. So this is still building the Windows server. Again, the domain controller. It's about 9 minutes in. Should finish. Like I mentioned, usually it'll take more than 15 for the whole thing. Okay. I might have had a demo fail here. You know what? Let me try to RDP, or first let me make sure this is still running. Let me try to RDP into this instance. It may be that I just have to bump it. Give me 1 second. Just open remote desktop. Like Rob mentioned earlier, these machines are, these instances are full-blown machines. There's nothing, there's no difference between a full-blown machine and this. It's running, this means it's running a full EC2 Windows server. Oh, finally it got connected. Never mind. I'll just wait a second. That took quite some time, usually pretty fast. There you go. So first thing, it's gonna go ahead and install like a Tommy Red team if it's not installed on the box, the agent, and then once it's installed, it like does some like minor configurations, and oh, something went wrong. Been seeing this where like WinRM sometimes will crash. Let me restart that instance, specifically this Windows domain controller. This range specifically has been running for a few days, so I suspect something wasn't going wrong with that instance. So let's just find it here in Firefox. Specifically this instance. Oh, no, that's the error. Just grab the right instance there. Oh, I am in the wrong account. Bear with me. Let me, and I don't want to destroy it and rebuild it because we're going to be another 10 minutes here waiting for this to destroy and rebuild. In 2 minutes, I'm logging into the AWS account for this instance, so I can go ahead and I'm gonna just hard reboot that instance, that Microsoft Windows instance. During the meantime, let's just keep checking the status on our other range build. It's getting close to being almost done. Here we go. All right, just to show you, this is the main controls. I'm gonna go ahead and reboot them. And hopefully, you know, when in doubt, just reboot 3 times. I should probably RDP into it, but I just for sake of time, I'm already gonna go and troubleshoot it. I'm just gonna reboot it. If it doesn't come up, we'll just wait for this guy to finish. And we'll use this as an example for attacking. We'll wait for this range to finish building, worst case scenario. But let's see. Well, that's coming up. Here, let me just do a list machine. Let's try to RDP. Make sure again the server comes up and it works well. There we go. Machine looks like it's back up. I'm gonna go ahead and copy the password for it. should be seeing now this Windows kind of login screen. Bro, can you confirm for me?
Yeah, I see the login screen. You're already being, right?
Yeah, I am. Just to
Yeah,
make sure.
it is. It is. Yeah, it is. It has to create a profile if you're logging for the first time, and then it should be the splash. There you go. You're in.
Sweet. Yeah, there, and it was complaining unplanned shutdown. Yeah, it was unplanned. Yes. Sorry. All right, so okay, so let's see if this actually took care of a little hang up earlier. I'm gonna flip back to my terminal. Here we go. All right, so let's try to launch this attack one more time. There you go. I think this time we're gonna have luck, I hope.
Yeah, it went through.
Yeah. Usually, again, it's usually pretty instant. You know what I've seen happen, I think WinRM dies. It's the away. Oh, never mind. It didn't.
Fell again. It seems to have an WinRM section, credentials.
Let me see something. I thought this is the case. But here, we have a, what? I made a mistake in the SSH key. I did complete. SSH authentication failed on this guy. No public key. And I did create my SSH keys. Yep. And it is on read only. Yes, it is. Okay. And who is the server? In 1 second, let me just verify this server. Oh, one nice thing is when things fail, at times, when you run Terraform, you may not have to rebuild from scratch. It's not necessarily a requirement, which is pretty cool. The Terraform will know, like, just to rebuild that instance that went bad. So I'm checking this instance really quickly just to see which is the one that I failed to log into. I think I must, you know what, did I change the, oh, you know what, that's the problem. I got it on the wrong region, CSC. I thought I saved this file. I must have edited and not saved it. Here, let me just make sure I'm in the right. Yeah, that's exactly what happened. How are we doing on time? I just want to make sure we're not cutting into another percentage time.
Nope, you have plenty of time.
Yeah, we're past time, but we'll stay as long as we, as they're comfortable with.
Oh,
No, you guys have, you guys have it until you're done.
thank you, Joseph. Yeah, this is good. This is part of the process.
Yep, you're not learning if you're not breaking something or running into problems.
Yep. Yeah, I made a mistake here. I never saved the config file, and I got so excited and I ran my build, right?
Oh, without it,
so
without the SSH key.
Well, without the key or without the actual region, which is why I was never seeing in AWS the
wrong IP
building.
addresses.
Yeah. It's okay. I mean, this is
Yeah,
we live to make mistakes.
people might do the same thing. Now they're learning from that.
Yeah. So here we are. I am going to again just run through the steps of what I configured earlier, and I'm going to go ahead and change my passwords. I'm going to put my Kali machine in here. Boom. And then I'm going to go ahead and just remove the let me do a destroy before I do this. Before I do another build, it goes ahead and destroys whatever is there now. You know what? Let me just wipe out the Terraform state. Uh-huh. I'm just rebuilding the whole Terraform thing right now. It looks like I broke it pretty bad. Here we go. And we should be able to do another build. This time around, hopefully we're in the right region. Let me log into AWS again and see this thing come up again. Flip here so attack range team 6. Oh, there you go. Now we're seeing the actual machines come up. That's why I was weirded out. I'm like, hey, why do I see the machines? Right. So now it's actually creating them. All right, let's just give it another whirl. While this is going, I'm gonna go ahead and destroy the other instance that we left dangling around in US West. Give me 2 seconds, just so I can do some cleanup. And then let me, again, just double check here the build process, make sure that's looking okay. All right. And also let me double check Discord. Can I help anybody? There's no dangling questions so far. All right, so this is coming back up. This is good. This range, I don't know what ended up happening here with the team 1, so the controller 1. We can do a destroy and rebuild too. Why not? How does that sound? Have 2 ranges for the lack of 1. Who doesn't like to multitask? Destroy, by the way, is pretty straightforward. You see here, like action destroy, and it's gonna literally undo everything it did on your AWS account. Destroy route tables, the VPC, the route gateway association, the actual server for Splunk, Kali, so on and so forth. It's literally nuking the environment from orbit. And sorry, I just flipped back to the build. This is already building Kali. Nice. So it's building Kali, it's building the Splunk search head, and the Windows server. So things look like they're progressing okay. Just flipping back here, if I look at US East 2, and I look at the attack range, Team 6, yeah, things are running, they're initializing, this is looking decent. Right. Back to term. All right, so all this is building attack range 6. Let's look at how my destruction of 1 is going. All right, so this is done. Destroyed 34 resources. I'm gonna rebuild attack range 1. Again, 2 is probably better than 1. But actually, before I rebuild it, something I didn't talk about a little bit earlier is the help file here, the CLI help file, and the different commands really that it takes in. We kind of talked a lot about this in the beginning of the presentation, but they are there's really two main modes we would expect everybody to use, right? Vagrant and Terraform. That's the flag you see me continue to pass, right? -N. And there's really only two required flags: mode and action. And the mode is Vagrant if you're doing things locally, Terraform if you're doing things using AWS. We highly recommend anything that you're going to share with teams and stuff like that. You're going to be using Terraform, unless you're doing some dev work. Vagrant. You typically don't use Packer unless you're doing something consistently. We're thinking about deprecating Packer in the future, just FYI. Again, we added this as an optimization, but Terraform has gotten so fast right now. We could do it in 15 minutes. It used to be 30. that now Packer's becoming less and less of a need. On the action side, again, there's a few actions you can run on this thing. You can build it, you can destroy it, you can run simulations, stop and zoom it. We really didn't cover a whole lot. There's other options like search, test, build AMIs, and destroy AMIs. Build AMIs and destroy AMIs is very specific to Packer. We're introducing the ability to run almost the attack range as again, as a part of a CI pipeline. So you can pass it like a unit test. And what that would do is you can bring it up, the attack, when you pass it a test file, or bring it up and then reading from the test file, it launches a specific environment, or builds a specific environment, then launches a specific set of attacks against it that you declare in the test file against the set of targets you declare, and then it checks for whether the detections that you specified on the test file caught that attack or not. So that's a pretty cool feature that I'm super excited about finishing off and sharing with everyone. It's how we plan to do automated testing of our detections. On the other flag, another major flag, again, is when you're running simulations or simulate, you gotta pass the target, otherwise it won't work. And you saw me do that a little earlier. The simulation technique is the technique from Atomic Red Team, which actually I forgot to share where that's coming from because we had that error, but I'll come back to it. I haven't totally hasn't totally locked my mind. I'm not even going to cover search name. We're thinking about deprecating search name and the search feature for in lieu of test. If you had another config file somewhere else, you can pass it. Again, the path in here. The test file is for the test feature. And then the other flags you saw is a list machine earlier, which actually prints out everything that's been built out or what the current status is, and then list searches. Again, the AMI is for the Packer feature, which also will likely get deprecated. This is pending a nice cleanup. Let me flip back here. Okay, this is still building. Sweet. While this is building, I'm just gonna go ahead and start building also the Team 1's attack range. If you're following along and you have your own attack range and you're playing with this, if you're just straight and building, again, any questions, comments, jump in Slack, message Div or Trahan. We're both in there. While Team 1 and Team 2 builds out, let me talk about how the Atomic Red Team technique flag works a little bit. So when you pass it a flag like simulation to me like T1001, what's really happening under the hood is it's going to go ahead and actually, T003, it's going to go ahead and leverage one of these atomics. And this is coming right from the Red Canary's GitHub project, Atomic Red Team. And if we open, for example, and by the way, now Atomic Red Team it supports sub techniques. If you're familiar with the MITRE sub techniques, which is pretty neat. But if we open T003 here, they have two files. The YAML is the actual configuration that runs, and then a README, a Markdown file. The Markdown file walks you through the different kinds of simulations that are really happening, or attacks basically are really happening when you pass this technique. So when we specify T003, it's really running these two attacks, so these two atomics, so they call it PowerShell Mimikatz and GSecDump, right? And if you click on PowerShell Mimikatz, you see a nice description of what that means or what that does, the actual command that is invoking on the system, and again, they're usually pretty extremely well documented as to what is it trying to accomplish with quote unquote that attack. Like Rod said, earlier, and I think it was also mentioned in Discord, the fact that Automata team is launching a sample of an attack doesn't mean that this is what all the invocations of this attack looks like. So this is, for lack of a better word, table stakes for like the most basic of detections. This is definitely not a deep and wide view of what kind of potential attacks can happen. For example, like in using GSecDOM. That's where other more complex simulation engines really take hold. Like again, Red Canary or like Scythe or Attack IQ. I'm going to click here on another simulation technique. For example, this is one of the sub techniques, 002, as part of credential dumping. And this is specific credential dumping for the security account manager, which includes dumping registries using reg.exe, dumping registry using, again, secrets.dump or pwdumpx. And there's a really, again, really good examples and documentation as to how this works. I'll be using this to demo simulation in 1 second, and I'll demo detection as well. Let me jump back to the terminal and make sure that build is going okay. All right, so it looks like we're about 9 minutes. We're about 4 minutes left, roughly, on this build. And this is still going. This is still building the machines out. All right, let's just wait it out. Any questions so far? We'll jump over here to Discord and make sure that anybody who has any open questions.
There's one open about an agent from Caldera. I'm building up a range myself because we've been having that issue for some time where the HTTP connect back works for a minute. It shows like it's working in the interface, but then it dies. So the way around that is usually you go in Caldera, look at the code, RDP into the Windows, paste it in the command line, and then it connects back. So I'm going to replicate it and post the screenshots on the actual Discord. I'm just waiting for the range to finish. It should be finished soon.
Rod, it'd be awesome if you can walk me through here too. I don't think I've ran to.
Yeah, I'll take a look. Yeah, I can actually show it. Let me get in and I'll do it because I had to deal with this when I was building the wiki. So it started happening. It started happening like like any vendor. They push new code, and then certain things don't work the same way anymore. So that's when we decided to fork one of the versions of Caldera. Patrick and I were talking about it, but let me once I get it and log in, I will show it here.
Thank you, man.
You wanna go over the dashboard, or show the dashboard where it shows the actual results from the execution?
Yeah. As soon as I'm gonna wait until I have 2 ranges, 2 builds going now. I'm gonna wait. Most likely this is gonna finish any minute now. I think it's doing the last portion of the install, which is set mount on the main controller. And then I'm gonna launch the attack and I show the dashboards and I show the attack results in there. And then maybe we can do, if you don't mind, Rob, like walk me through this Caldera issue. We can show everyone like, hey, this is how you run it and run into it and how you resolve it if you do at home.
Yeah, let me get onto this the Caldera server. Give me a second.
Yeah. There you go. For those curious, actually I have another range I can show the dashboard in. Wonder how everybody else's environment is doing. Hope you have better luck than I did with my my team 1 environment. we go. Come on, faster. I have zero patience for waiting for this thing to finish, which is the result of the packer mode. And a lot of the wait time is not necessarily, it's just things on Windows machine takes a long time in AWS. Oh, there you go. Team 6 is built again, successfully this time, which is great. All right, so let's go to Splunk really quickly. Again, just make sure that it came up and we can see it. 30,000 and username is admin. Let me copy and paste the password that we had set earlier. There you go. 0 attacks so far, great. And again, just running through this again, I always make sure data's coming in. So we got a little bit of data in there. Let's launch an attack. Oh, let me flip back to the terminal. Action, simulation technique. Let's do T00. I mentioned earlier 02, which is the credential dumping from the security account manager sub technique. And then the target is going to be our domain controller. So pass the domain controller name. And let's see. And then after this one works, let's view hopefully when this works, let's view the results, and then we can jump into Caldera and do something Caldera. So again, it checks whether Atomic is installed. It's gonna go ahead and install it if it's not. And then run the actual attack. There you go, ran the technique correctly, it's cleaning up. And so we successfully executed technique T00302 against the target. Let's flip back to Splunk and we should see that our launcher page now, we should see an actual attack in here. Or not, just kidding. It takes about a minute for the data to come and get indexed. You know what? Let's just search the index directly. So if you go to index attack, see the last 15 minutes. Interesting. It makes, let's see if I find logs for this. Should be seen. Am I in the right server? 227, 249. Yep. Oh, you know what I think I'm at? Is it 2 zeros in the simulation technique? Let me see here. I was for it. Oh yeah, it is. Okay. Oops. Let's try this again. I messed up the simulation technique ID. It's 2 zeros. 2, right? Or 3 digits. Right. That seemed to have worked again. Let's go back to Splunk and refresh this. Oh, now it got me an error, so this is progress. Yeah, if we go to index attack range. Oh, there you go. Okay, perfect. So you can see, again, we write all the attacks into this index. And we can see here we launched 2 tests, test 1 and 2. Specifically, the registry dump of SAM, creds, and secrets, and registry parse with cats. And if we flip over to Atomic Red Team, on this technique, that's exactly the 2, right? Registry dump of SAM, creds, and secrets, and registry parse with cats. Now, if you wanted to see what this a detection search looks like for this technique, we have one in our enterprise security content update. This is, for lack of a better word, the bread we make for Splunk, our detections for these attacks. And we have specifically a use case here for credential dumping that has a bunch of detections. And I know there I have one specifically for that technique of registry dumping through the reg.exe. I just got to find it. Here it is. So this is the search. I think this should work out of the box, but I may have to modify it slightly. But this is looking, oh, there you go, it worked, perfect. Yeah, so this search is looking for any process commands with reg.exe or command.exe that has the keyword safe under any of these registry keys, HK local machine security or HK local machine SAM or HK local machine system. And you see here, there are a few instances where the command CMD or reg.exe actually ran what looks like a 10 test dumps, right? And again, this is Atomic Red Team doing it. So this detection works. Awesome, as we would expect it. So we launched an attack. You saw what that attack looked like, and this is the detection for that attack. Now let's look at Caldera. Let's look at Caldera. There's simulation engine. So port 888, I send that over with instructions from whomever's running on their own range. Because I replaced all the passwords with my own password. I'm just going to use that password in here, and Caldera came up.
All right, I got it. If you want, I can guide you through. I can show where the pencil. Let me know what you want to do.
Yeah, please guide me. So I'm here on the agent.
Okay, right. So as you can see there, the PID is showing that the agents are dead, right? So click what it says. Click here to deploy agent on the left, and then select. Click on it. Yep. I don't see the menu yet coming down. You have to click on the white, on the arrow.
Yeah, here, I think it's not showing because it's sharing. Interesting.
Well, let me I look at mine and I can tell you exactly what you need to click on. So you choose A and you're gonna select man X.
How about now? Can you see? I think it's something to do with it, the way it's sharing. Can you see?
No, I still can see it, but I can select man X, which is reverse shell.
Okay.
Via TCP.
Reverse shell agent, TCP communications. Okay.
Right, now scroll down
Uh-huh.
until you see the Windows icon and see TCP. You see that?
Okay.
It's a reverse shell via TCP. Yeah, so go ahead and copy all that code.
Okay.
All of it. All right, so now what we're gonna do is we're gonna RDP into the Windows server.
Oh, okay. Give me 2 seconds. Let me bring up RDP. So I'm going to share RDP here. And let me find my Windows Server IP address. 2 seconds. I'm gonna go ahead and add an UBC. And then I'm using an administrator. And then the password.
Yeah, the password.
Right. Give me 2 seconds. Password. Right. Continue.
So once you log in, I'll tell you exactly what you need to do.
Windows is just logging in. I'm not sure if you're seeing that or you're still.
I'm not seeing it yet. You may have to change the actual screen.
Yeah, let me try it here.
Yeah.
How about now?
There we go. So do this. Go where it says Windows key, type run, or do right click run. Right click on it. It's just double fingers. There you go. Type notepad. Enter. You should see notepad coming on. Paste the code.
Let me go grab it again. Sorry.
Right.
Seconds. So the Windows show.
Right. For those who are asking, you have to select the code that is to the operating system we're trying to get to. So in this case, it's window. Now you want to go to the beginning of the string, and then you're going to change the IP address where it says 000 to 10.0.1.12. And then on the next one, yeah, that's the default Splunk server Caldera. You see what it is? You see, hold on, we're not done yet. In that one as well, 10.0.1.12. Now do edit, select all.
Okay.
Copy. Now go back, go to Windows, the Windows menu, and then do right click run. CMD? Or yeah, CMD. And now once it opens, type PowerShell, and hit enter. Excellent. Paste it. Enter. And now go to your Caldera.
Give me 2 seconds. I'm just going back.
I don't know, but yeah, we're kind of going around this. Go to your Caldera, and now go to agents. Refresh. Ta-da, there it is. Yeah.
Got a live agent. That answers questions. Thank you, Rod.
Of course, man. So
then I should be
right. You okay? You know how to do the operation, right? We had to go to adversaries, and then on adversaries, we're gonna select a profile, and we're gonna save this profile. So do an easy one or you can do several so they can see it, because as you select different profiles, you will see the operations or the abilities like Caldera Miter says that you can do. So we can do one that the discovery is usually pretty nice to get started. So you select in the profile discovery, and you can enter a profile description and save it.
Okay, so I'll pick discovery.
So if you see in the actual discovery, those abilities will tell you things such as it's going to try to view admin shares, it's going to try to find if it's a domain controller, it's going to try to find if it is an antivirus program. Now notice that there are icons, and these icons tell you if this is applicable for the operating system in the targeted host where we're running our agent, right? So let's save discovery, and now we'll go to campaigns. And what we want to do now,
save it.
And now go to campaigns.
Here we go.
Operations. Yeah.
Okay.
So now select an operations, discovery, or you can click view. No, you should be able to see it. Okay.
Operation name test.
And then click on basic options. And then, so you can see, for example, the groups. You can divide groups of agents, for example. You can select profiles like we looked at. So click on the profile, for example.
Discovery.
Yeah, there you go. You can tell it keep open forever, or there are other options, and then you can do run immediately. And once you hit start, watch it. It shows up on the right, and it will show you the progress and what's happening. Like right now, it's trying to identify the active user, right? See, 4%. You see how it changed? So this is how you do your operations, basically.
All right, 8%.
There you go. It is. It is working on. Yeah.
It's doing its thing. So this is running, Rod, all these discovery exercises, basically, huh?
Right, based on the profile you selected. There are others. There is worm-like behavior. There is actually, I believe there might be a specific adversarial emulation. But interestingly enough, It's not like the atomic where you get the identify technique. That surprised me a little bit. I was expecting to see a menu with the techniques and then go for it, but it's not. I'm sure they will put it at some point. So now that we finish, this is what I did at the end of my presentation, which basically you notice that you weren't able to view admin shares, so that failed, right? So we can actually look at index and the index, a win index, and you will see the execution of the agent, which you can find by basically going back into the agents and looking at the name of it, and then searching it within index equal win, and you will see what it's been doing basically.
You want me to go ahead and do that really quickly? Since I'm already here.
Yeah, you can go. You can search. Do you remember the name of the agent? If you go right, I don't think that's the complete name, but you can always go back to the agents and.
I'll try to rock it. Yeah, this is. I know it starts with that. Let's see.
There it
There you go.
is. There it is. You see that?
So Windows event logs.
So now you have the full Magilla. You go from the building to the execution to we're finding it. Gives you process ID, gives you the executable. So this is an amazing tool for researchers. I love this. I always wish I had something like this. It took a lot of time in the industry to get to this point, and obviously we didn't have the technologies we have nowadays.
So Rod, the agent in this case is the host name. Is that what it matches on, the field? I'm trying to find.
No, the agent should be under an executable.
Oh, see, creating script log of text.
Yeah.
I'm seeing it on the also. Maybe if I don't specify an index, I wonder if this shows up anywhere else.
This should show somewhere else too. You should see in the index there. There you go.
Yeah. So it's showing up in the sysmon events through PowerShell, execution bypass, and then some command. Cool. Very cool.
Yeah, it's a little tricky. And guys, we're dealing with this as you are. You can see the operation is still going, and some things will apply, some others would not. Again, I want to emphasize this. When you do this, you want to use your golden image. Your golden image is your ISO, your bare metal workstation, your inventory approved of whitelisting, blacklisting applications that you're going to run against this test in order for you to know, oh, if we were attacked by this, then this is what would happen, right? So always remember that if you don't use a golden image, you are not getting a representative result of what happened within your environment. If you're a blue teamer, for example, if you're a researcher and you're not looking at this as a perspective of defense, but it's a different focus. You look at this mostly from the writing a signature or like we're doing a Splunk, do some SPL, Kung Fu, and finding maliciousness, creating tables or dashboards. So.
Great. I'm gonna end it here if it's okay, Rod.
Yeah.
I think we covered quite a bit. I'm actually kind of happy and thankful that things didn't work exactly how we expected, because everybody got a good taste of like what troubleshooting the attack range looks like also. But yeah, this should give you a really good experience to like how do you build things, how do you launch an attack, how is it pieced together. Again, we're gonna be around in Discord if you're still playing with this thing. The goal is to destroy all the provided labs by first thing tomorrow morning. So they'll be around for a little while. If you want to keep kicking around inside of them. And yeah, again, Rod and I will be in Discord. Otherwise, you can find us on Twitter. This was fun.
Yeah, thank you guys.
Yeah, I was gonna say thank you, Joseph, and Texas Cyber Summit team. You guys have done an amazing job putting this event together,
Yeah.
and we really
Thank you
appreciate
very
the
much.
opportunity.
No, thank you guys. I mean, you provided a lot of resources for the attendees to be able to learn. We're not charging for this. You're not charging for this. So this is all about taking care of the community.
Yeah, you guys can reach out to us anytime and expect more from this tool. We're gonna be delivering more, and there will be other stuff that we'll be adding to the attack range. Hopefully, with this tool, you will be able now to create your own signatures, and you'll be able to share them with everybody. Same thing with new research and new exploitation. So I wish you good luck and success using this tool.
Thank you, Rod and Jose. You guys have a great rest of your Sunday.
Thank you.
Same. Definitely.